It's my great pleasure to introduce Eric Butler and Kristin Siu, who are integral parts of the creative team behind Elsinore, a time-looping Shakespearean interactive narrative game. Eric Butler received his PhD from the University of Washington, where he worked on applying formal methods to game generation, educational technology, and design tools. Currently, he's a technical lead at the nonprofit educational company nLearn. Kristin Siu is a PhD candidate in the Entertainment Intelligence Lab at Georgia Tech School of Interactive Computing. Her research looks at human computation games and other problems at the intersection of games, human-computer interaction, and artificial intelligence. Currently, she's a software engineer at Microsoft's Mojang Studios, working on the education edition of Minecraft. Eric and Kristin are partners and kindly agreed to give a joint keynote on the challenges of designing and implementing Elsinore. So please welcome Eric and Kristin.
Yay. Okay, so thank you very much, Stephen, for the very nice intro. So good morning, everyone. Thank you for coming this morning. It's a little early for us. Hopefully it's midday for everyone else. So we're, as Stephen mentioned, we're two of the developers on the time-looping Shakespearean game Elsinore. And this talk is about the game's narrative simulation, some of the challenges that we encounter building that simulation, and our thoughts on how AI and technology could help build these kinds of interactive experiences in the future. So yes, as Stephen mentioned, I'm Kristin. I work at the Entertainment Intelligence Lab at Georgia Tech. And while my dissertation work doesn't directly involve interactive narrative, and this game has nothing to do with the work I do in the lab, I was able to bring some of my exposure to and experience with it to this project.
Yeah, and as Riku mentioned, my background is in formal methods and building like AI-driven tools. And so that's the experience I brought to this project to try to build this narrative simulation.
And this game was made by a team of friends and professional game developers as a side project. So we're all game development or software engineering professionals by day, indie devs on the weekends. And we're the two members of the team who have an academic background. We're also the two engineers and system designers who were responsible for working the most closely with the narrative system. And we also worked very closely with our writer, Katie, and our designer, Connor, to make some of the things that we'll be discussing today possible. And so very quickly, what is Elsinore? So Elsinore is basically Groundhog Day set in Shakespeare's Hamlet. In the play, you'll play as Ophelia, who's one of the characters in the original play, stuck living through the tragedy of the play over and over and over while attempting to change the tragic outcomes. So first, what is Hamlet? So familiarity with Hamlet is not relevant to understanding this talk or even playing the game, but just as a brief overview for those who might not be familiar, Hamlet is the longest and arguably the most famous of William Shakespeare's tragedies. It's a staple of many Western high school and college English classes where it is pretty thoroughly dissected and analyzed. So there's a lot of scholastic material on it. And here's a very quick lightning overview of the plot. So the titular Hamlet is the Prince of Denmark. He's very unhappy that his uncle Claudius has become the king by marrying Hamlet's widowed mother Gertrude. And at the start of the play, he encounters a ghost who looks kind of like his recently deceased father, claiming that he was murdered by Claudius. So this starts a long plot to avenge his father by feigning madness and not really doing anything except brooding for most of the play. There are other characters such as his love interest Ophelia, who you play as in Elsinore, her family, and all of Hamlet's friends at the Danish court. And then all of this is sort of overshadowed by an impending invasion by Fortinbras, who is the Prince of Norway. And TLDR, at the end of the play, everybody is dead except for Fortinbras and Hamlet. And so how does this plot translate to actual gameplay? So in the original Shakespearean play, Ophelia does not have a particularly large role. It is frequently sidelined. So she's basically treated as a damsel in distress. And similarly in Elsinore, the player as Ophelia is not given a lot of agency to take direct actions. So she can't just walk up to a character and stab them, which might be the really cool kind of action you would be able to take in a typical adventure game. The main way Ophelia interacts with the situation around her is by eavesdropping into the events that she's seen and learning information, which she can then pass on to other characters. And so this creates the core loop of the game, wherein Ophelia learns some information. She can then take this information back in time with her using this time looping mechanic. and then use it to try and influence other characters who might not have known about this previously. This in turn can shift what events play out, which, given that it's Shakespeare, probably results in some further tragedy.
Yeah, so I just wanted to give like a really concrete example of that illustrated with screenshots from the game of this loop. So here's a picture of a scene from the chapel where Claudius is confessing to the murder of his brother, which in the play Hamlet's overhearing. In this one, you as Ophelia can also eavesdrop on it. So Ophelia can't interact with the scene very much. He just witnesses the scene, and from it you learn this information. You actually like get it as a piece of in-game inventory. This idea that Claudius killed King Hamlet, and since she is stuck in a time loop, she can take that information back in time with her and keep it. Hamlet wants to avenge his father, but due to like weird dubious plot reasons, and this is like what Shakespeare came up with that we just used, he just can't kill Claudius right now because he's in the chapel. That wouldn't be bad. He has to do it some other time. And so the normal events of the play occur where Hamlet just kind of broods a lot instead and winds up with everybody, including Ophelia, dying. All right, so you go back in time. Next loop, Ophelia can say, aha, I'm going to run straight to Hamlet and tell him what I learned. Tell him that his uncle killed his father. And now in this different context, Hamlet not only believes you, because he has already seen the ghost by this point, so he has some idea that it's true, but he not only believes you, but he now has the will to act since it's a different context. So you can sort of see we're actually reading out Hamlet now believes King Hamlet was murdered. That's like a piece of the game state that we literally just when a scene changes something like this, we just like straight up tell the player the thing that changed so they can try to follow along with what's happening with the characters' wants and desires. And then he goes ahead and he does it. Things turned out a lot differently. So you through this interaction with Hamlet by spreading information dramatically changed the outcome. But this being a tragic game that is more than 2 loops long, things still kind of go off the rails and you and a lot of other characters wind up dead. But the idea is that you will go through these loops over and over again, and each time when you branch the narrative, you can learn new things about the characters or acquire new pieces of information you can use to attempt to manipulate those characters on future loops, eventually achieving a somewhat better outcome. All right, so I want to go into a little bit of detail about how the game's simulation works and how we put it together. Like many other interactive narratives in similar ones, it's made of a bag of events. So the event's kind of like the core atomic piece of the game. So here's like an example of a chain, like a little mini arc that happens both in the play and in the default loop. In this case, early in the first day, Rosencrantz and Guildenstern show up at the castle and meet with King Claudius, and Claudius asks them to spy on Hamlet. These events are just preconditioned on like predicates that are in the state. In this case, Claudius begins the game wanting to placate his nephew, and after this event occurs, Rosencrantz and Guildenstern now want to spy on Hamlet. This in turn triggers the precondition for another event later that afternoon, where Rosencrantz and Guildenstern greet Hamlet, and Hamlet sees right through what they're trying to do and sees that his uncle's trying to spy on him, and so now he wants to avoid Rosencrantz and Guildenstern so they do not get any information. That in turn leads to an event the following morning where Rosencrantz and Guildenstern go report their failures to Claudius. So while this idea of like events that are interconnected with preconditions and postconditions is like very common structure for interactive narratives, Elsinore has 2 things different about it that make it a little bit unique amongst its contemporaries. And that is we decided for artistic, but perhaps dubious reasons, to situate the game into a 3D virtual space with a real-time clock, right? So here's an example of the map that the players see. Characters have to like literally walk 2 rooms to go to events. Now, obviously, because it's happening in a space, you can only have characters at one event at a time, and you can't have multiple events in the same room. And at the same time, because there is a virtual clock, there's a real-time clock, there's a limited set of ways that the events can play out, right? So we, in fact, even give the player a visualization of the schedule events that have happened in the past and ones they know might happen in the future so they can try to figure out what's going on. And because of these decisions, we've kind of set ourselves up where the core component of Elsinore's simulation requires solving like a classic scheduling problem. We need to figure out which events need to happen. And I think it's worth bringing up a little like distinction here about how the characters work The Elsinore characters are less like AI agents in a sense of like they don't have individual rules and behaviors that they're like locally applying and making decisions. They're more like puppets under the control of a AI director, which is the scheduling algorithm, deciding which things need to happen. Right. So because we put it in this virtual space, this lets us achieve kind of like this important aesthetic goal we wanted, which is that multiple events are all happening at the same time in different places. So you can tail a character around and follow them as they go about their day. You could just stand in a room and see all the different events that play out in that location. We were heavily inspired by games like Majora's Mask, but also the theater experience Sleep No More by Punch Drunk, which was Macbeth, but similar experience, but like live performance Macbeth, where you had to make decisions about who you wanted to watch and where you wanted to see scenes. And in this case, in Elsinore, you can not only do this, but you can try to dramatically impact how these things play out by interjecting with the characters in the middle. All right, so that's how it works. I wanted to talk a little bit of how we built it, because I think that's relevant. And it was an evolutionary process between Kristin and I, the like systems engineers and designers, and Katie and Connor, the writer and the designer, where we, over the course of the project, slowly built and iterated on a custom domain-specific language that's used to control Elsinore. And this language and the mechanics evolved with like, as we were evolving our artistic goals and figuring out how to make the experience we wanted to make. So I can just show you like a real example real fast of one of the events we had earlier, just so you can kind of see what our writers were working with. This is the scene where Rosencrantz and Guildenstern try to greet Hamlet, and Hamlet sees through them and understands that he's spying on them. I think the most important bit worth highlighting here is this part is where the actual game state is being modified. So we just represent our game state as a big bag of predicates. It's worth mentioning, I think, like these predicates, because the characters aren't really driven by rules, it's more just like the events define what happens. These predicates don't really have any like inherent meaning to the game simulation. Like it doesn't know what once or believes means. It doesn't know what impress or avoid means. The meaning of the state is given entirely by the event preconditions. So it's the mechanics in some sense are like largely in the content, and specifically in like the event content, so directly under the control of the designers. I also want to mention briefly like the reason we're using a textual representation. We were in a fortunate situation, we were able to do that. The motivation was partially that both Katie and Connor, while not like engineers by trade, are proficient enough with programming that they can find their way around a C# file just fine. So they're comfortable with a textual syntax. And also as a like very word intensive game where you're going to be typing a lot of lines anyway, text is a reasonable approach to try to, so they don't have to spend time bouncing back and forth between the keyboard and clicking around through a more graphical interface.
Okay, so Eric has gone over Elsinore's narrative systems, and so many of you in the audience have probably been thinking, hey, this probably looks pretty similar to some of the stuff that I've already seen out there. So to sort of better understand some of the challenges that we're going to encounter, I want to talk a little bit about the context in which this game was created in and how Elsinore sort of compares and contrasts against other narrative systems. So let's jump back in time a little bit. We started building this game as a side project back around 2013, 2014, and we were thinking of it as being sort of in the middle of this spectrum with tightly scripted games on one end and simulation games on the other. So on one end of the spectrum, you have games with tightly scripted narratives, like Choose Your Own Adventure books, or games like The Walking Dead or Myst. And on the other end of the spectrum, you have simulations, and here you have things like Dwarf Fortress or The Sims, where the narrative emerges as a consequence of play. And in the middle, a lot of people have tried to tackle this problem. And so you have experiences, and the two that I'm going to compare and contrast against are Facade and Versu, which are trying to be a blend of both. So have some of the nice properties of tightly scripted narratives, but also some of the really nice properties of a simulation. And so let's take a look first at the left side of the spectrum, which is like these tightly scripted narratives, we wanted handwritten scenes in a more controllable story where the events and their progression resemble a Shakespearean tragedy. But unlike something like a choose your adventure game or choose your adventure book, where the sequence of narrative events can be more easily controlled or basically outright defined by the author, Elsinore forced our writers to reason about the system's behavior and how to wrangle the simulation to do what they wanted. If we jump to the other end of the spectrum, where we have simulations, the narrative is constructed by the rules of some overarching system. But unlike a simulation, we care about not having completely unexpected outcomes. So for example, in Dwarf Fortress, a fail state might be that all your dwarves die, but having your fortress overrun in a hilarious cascading way is something that is frequently embraced by the Dwarf Fortress community as a really good and fun story. In Elsinore, unfortunately, our end states need to be appropriately Shakespearean. So they need to be, in this case, tragic, which requires us, again, to sort of coerce the simulation to behave in a way that we consider reasonable. So these are many of the same challenges that games like Facade and Versu are trying to address. So like a game like Facade, we are situated in a virtual space. We have a bag of events. Facade has a bag of beats. And both of these bags contain many handwritten scenes that are played out in some kind of progression. The difference between us and a game like Facade is trying to optimize for something different. So they're trying to optimize, the system is optimizing to create drama and to create a dramatic arc. Elsinore is sort of scheduling things to prioritizing rooms and a lot of other sort of rules and properties that we'll go into in a little bit. So what about Versu? So like Versu, we also share many things in common. We implemented our own DSL, much like Versu's practice. In fact, we went through many of the same iterative steps that they did. And we also do things like lightly specify some rules about how narrative arcs are allowed to play out. But to contrast, Versu's characters are more agent-based. They have more sort of per character properties, behaviors, and rules, whereas Elsinore's characters are, as Eric mentioned, puppeted by this global scheduling system that doesn't really understand the semantics or modify any of these behaviors specifically.
I want to give a particular shout out to Versu as a proximate inspiration for the development process we did with our language. I think it was 2013 that Richard Evans was giving a keynote talk about the process behind building the Versu DSL, and Emily Short was also pretty instrumental in giving us some early feedback on the game. I think initially this project started as literally choose your own adventure Hamlet. That was Katie's vision. And then I come back from Aiden having done some early grad school stuff being simulations everywhere. And we just sort of tried to compromise and put it in the middle here. And we initially had sort of chained the events together kind of much more naively, where it's oh, this event causes this other event directly. And that became really unwieldy. And it was people like Emily who were hey, you should maybe make your state actually have some kind of semantic meaning to your not to the engine, but to the writers, right? So that's why it's shifted from this event causes this other event to this event makes Hamlet want to do stuff, and this other event happens if Hamlet wants to do that stuff. So yeah, so overall we think the experience worked out really well. It was well received by players and by critics, and we were impressed we managed to kind of cobble something together that people seem to enjoy. But we're going to focus in this talk on kind of talking about the problems we ran into putting this together, and particularly the challenges that the designers encountered and our struggles to find these issues in the first place and then to overcome them, and our attempts at using more AI to fix it, and how we think intelligent narrative tools have a really big role to play in helping create games like this in the future. So the first one I'm going to go into detail about, as you may have guessed would happen, because we decided to put a bunch of artificial constraints on when events can happen, is that we ran into lots of scheduling conflicts where the designers are I can't get this event to happen. My favorite bug in this vein, which was there almost till ship, I think, is that it has to do with endings. So the loop is 4 in-game days. We kind of just compress Hamlet down to artificially 4 days. And some major ending event that causes the game over screen is supposed to happen within those 4 days. And kind of once you're in the mid-game, the default generic bad ending that happens is Fortinbras invades the castle, and now just everything's kind of over. Everybody who's not dead gets captured. But there was a bug where if the player was doing certain arcs in a certain order, just Fortinbras wouldn't show up, and the designers would have to like come to us and be like, we can't figure out why this event is triggering. This is a really common problem with these narrative simulations. The designer having to go to the engineer and be like, why isn't this thing I want to happen happening? Or why is this thing happening that I don't want to be happening? Like the preconditions were pretty straightforward. It like almost guaranteed to occur, and they happened to be true. So clearly it was like a resource conflict problem. And when we dive into it, it turns out, oh, this event happened, which pushed this other event back a bit, which shifted this other one back a bit. And like at the end of the day, there was a direct conflict between this and a minor character event where Horatio and Gertrude are like taking a stroll through the garden. So like Fortinbras is just standing there politely waiting until the room reservation's up so he can invade the castle. But it never happened because the like length of the events, there was not like a time window for it to happen. So I mean, like there's two challenges having to do with this. Like one of them is how do we even find these problems in the first place? And the other one is how are we going to go about fixing the problem? So finding it, in this case, we actually tried to do some things. Like, I mean, I have a background in formal methods. It's like, this is an easily characterizable property. I should be able to formalize this. I'm going to treat this like a verification problem. Like, it's like, in some sense, this is like a program correctness issue, right? Where the program is the event content and preconditions, and correctness here in this case, we can like write down some specs to describe what we wanted. In this case, we should always conclude with some kind of ending event. And if we don't, that's a bug in our content. There's a bunch of other problems that we encountered in practice that fit into this idea of like easily formalizable bugs. One of my favorites that we definitely did ship with, I think, was that Polonius could run on water. And what's going on here is that there's a boat that you can be on. This is the boat where Claudius sends Hamlet on to go be killed on his way to England. He fails in this, and here's the play. Ophelia can be on this boat and have some hijinks with pirates and Rosencrantz and Guildenstern and Hamlet on the high seas. When we had initially implemented the game, we had just started with the castle. So the simulation does not model like physical space or constraints about like whether characters can move between those spaces, because there was not reason to. And it's like, that's just like a bunch of complexity and performance hits to do for not a lot of value. It's just a castle. Then of course we added something that is physically restrained away. And it's like, oh, whoops, now Polonius can fly to the boat I think he comes there to tell you that your brother came back from Paris, and sometimes he'll come there and drag you off to an asylum. So he'll just like swim to the boat, grab Ophelia, swim back, and throw her in the dungeon. But this problem, like the other ones, we can kind of easily characterize what's going on here. The event's preconditions should have accounted for the room being unreachable, which is how we had to fix this particular bug in the end, is just kind of stamp out those events so Polonius can only come talk to you if you are not on the boat. I would like to say that we were able to make progress discovering things, but I think, but we didn't. Despite having like a background in doing this kind of stuff, we did not make very much progress in finding these. We ended up having to mostly rely on the same thing everybody in game development typically does, which is that whatever we happen to stumble upon in QA or playtesting were the things we could address. There's a lot of, I think, factors that go into why we weren't able to build out like distilling as much as we want, but the biggest reason is that like it takes somebody basically doing like dissertation level work to build some kind of fancy analysis system to go over a game engine and discover interesting properties automatically, and then also takes a whole team of people to actually build the game in the first place. And we were spending all our time fixing UI bugs and not able to build all the tooling we needed for the designers. So, okay, discovery we had to do by hand. How did we actually fix it? So I'm going to go back to this original bug with the Fortinbras invasion being canceled. It's kind of an interesting example of a good instance of a broader issue that kept cropping up as we built this game. All right, so at its core, the problem is a resource conflict that we had. Admittedly, if we got rid of the virtual space or the real-time clock, we could get rid of this resource conflict, but we wanted those for artistic goals, so it's there, we got to deal with this. And the issue is that the Gertrude Horatio walk event started too late and the fork raw event now can't happen because like the latest window it could plausibly happen is too small. The way that we ended up characterizing this thing to try to not fix just this instance, we wanted to try to do a systematic fix where we got rid of all like kind of minor side character events, like causing really crucial spine like plot events from not happening, right? So the designers went through and characterized every event as either kind of important or not, with the idea being that unimportant events shouldn't be impeding important events. Excuse me. So what are we going to do about this? The naive thing is you say, aha, well, we could just have one supersede the other. But that was not really an option for our game for both artistic and technical reasons. I think the main reason is that things that seem like atomic events to the player's perspective are actually like a quick succession of little mini events. Like anytime you are like clicking on observation bubbles or characters are standing there with speech bubbles while the clock is running, those are all actually separate events that are chained together. So if you start truncating events, then like they'll start the garden troll, get through like 3 sentences, and then just like awkwardly walk away because the event was canceled, which we didn't really want. And also that would have caused havoc with the game state because now only like half the post conditions may have like been set appropriately. So what we really needed was for the garden walk to magically not have happened in the first place. So this means that our initial implementation of the scheduling algorithm, which was quite greedy, just whichever events preconditions were available on a game tick can fire, needed to be made somewhat more complicated. And the systematic hammer we tried to throw at it is adding a little theorem prover into the scheduling logic. So the core thing the scheduler needed to ensure in the game is that unimportant events are only able to happen if they like definitely will not cause this kind of resource conflict with an important event, right? Like, so I'm not going to go into like very much detail about the algorithm, but like the basic approach is to say, if you want to answer the question, is it possible for some important event that shares either a character or a room with me, this unimportant event, is it possible for that event's preconditions to become true like within the duration of this unimportant event? And this sets up like a recursive algorithm. It's like, well, how do the preconditions become true? Well, if there's any other events whose postconditions set those preconditions to true. But since the time window now shrinks eventually to a base case of like, are these things true right now? So that's what we did. And I mean, it did its job, but it was a bit of a blunt instrument and it sort of created some more problems. By blunt, I mean that this kind of big systematic hammer lacks precision in that it stamped out a bunch of things, like this unimportant versus important events. We were able to stamp all those out, but it doesn't stamp out all the problems. This does not help you with 2 important events are conflicting in some bad way. The designers still have to track that one down and figure out how to modify the events to do it. You still have the same discovery problems as before. And we just kind of gave up on unimportant events conflicting with each other. We're just like, oh, well, I guess they're side arcs. Sometimes they'll run out of time and not actually happen. So in addition to lacking finesse and precision, it also sort of made things worse because, like, I guess the way to say like what happened here is that we had a simulation that the designers were trying to like wrangle control over. And there was an issue of both understanding and an issue of control with that simulation because it's unpredictable and chaotic. And then we tried to fix a problem with it by adding more system and more simulation, which makes it even more unpredictable and more chaotic, right? Because now we go from problems where, oh, I can't figure out why my event isn't happening, that boils down to either the preconditions weren't true or the like resources were in conflict. So now sometimes the answer is, oh, this event's not happening because it magically knew that it would be in conflict with some other event later. Good luck, designer, like figuring out that on the spot when you're busy trying to focus on other things like writing or animating or putting together like a character arc, right? And so I think a recurring theme of what we learned in Elsinore is that if you try to fix the weird things with your system, run by throwing more systems at it, you are digging yourself in a hole that we need to try to get out of some other way. Another kind of class of problems I want to dive into that is in some senses a little more interesting are ones that are not easily characterizable. So like all those problems I talked about, they were like pretty bad, like I used to like buggy failure states in the simulation, but I at least can write down pretty concisely and formally what I mean by them. And so we could, in theory, have had a computer check to see if they were true or not. But there's a lot of really important issues we ran into that we can't even do that. And like me with my formal methods background is kind of like terrified about how to even approach these. I think the most canonical example of this that we were fighting constantly as the game evolved was characters going through kind of like really implausible emotional arcs. So there was no systems controlling like the character didn't really know how in the shipped game, the character doesn't really know how they feel or what any of these like bits of state mean. So if you're not careful when you're sequencing events together and you have interlacing plot arcs, you might have a character go from some neutral scene to one where they're in like a deep despair because their loved one died, followed immediately by them like chilling with friends playing cards, followed by them literally murdering somebody, to then like a romance scene. And it's just very jarring and kind of uncomfortable in a lot of ways. So we needed to figure out how to fix these. And we have the same two problems as before of discovery and solving it. So I'm not even going to like talk about, I don't even have like that many ideas about how we could have done a better job discovering them. Like with the more easily characterized problems, we ended up only discovering them by bumbling into them. I think in principle, this is a place where more AI machine learning based approaches could work over more formal approaches, because I guess what makes these scenes weird has to do with like the common sense knowledge the reader has of like plausible emotional journeys for a person to go through in a short period of time, and like how they bring that to the work. And like that is some kind of background knowledge we could presumably try to learn and leverage. But yeah, for the most part, discovery, we just had to stumble across them.
Okay. So you might say, but wait, you solved this previous problem by adding this notion of like importance to your events. So like now events can be like important. And so you've added this like parameter to like what you've done. So you might ask, well, why not try and model something like emotion or sort of implausible character arcs or something like that. So so on this subject, you know, are the slides advancing? I can't really tell. Okay. So it's like, can you solve this problem with like more simulation? So can you like can you let the system know things about like, can we track like all the characters' emotional states, or things like how much they trust Ophelia, or like how particularly tragic like a certain event is. And so this is all well and good. And this is actually something we tried pretty early on in development. So one early idea was to let the system track properties like how much they trusted Ophelia. So an example would be like, you have an event, and depending on how much the character trusts Ophelia, then you'll get different preconditions at the end of the event. And this is something that you might see in a more agent-based system, or there are other various narrative engines that will let you do things like player statistics and like track these. And that feels pretty similar to that. So in this case, we tried prototyping this notion of trust. So like, how much did they trust? On one end, you had like, they didn't trust Ophelia at all. They thought she was insane. And on the other, you had this idea that like they trusted her completely. And it was like, oh, well, this looks great. You know, now we can, you know, put trust into the scheduler, and it will use this to help us figure out, you know, what events play out. But unfortunately, this quickly spiraled into a lot of chaos because our writers found this way too complicated to work with. So for Katie and Connor, it was already hard enough to reason about when an event might occur and sort of wrangle the simulation to like make it possible. But now there was this little parameter that they were tuning, this like trust sanity parameter. And it was really hard to sort of adjust and tweak it. It's like, oh, you have this number from, you know, either 0 to 1 or 0 to 100, what have you. What does it mean to increase it by 10? And in order to make this scene appear, I have to increase this, you have to change this parameter from like an increase of 10 to an increase of 15. But like, what does that mean for all the other places where I've tried to increase the parameter from like by 15? And so this just quickly became super unwieldy because they were trying to make events happen that just weren't happening. And once you sort of mucked with one event, then all the other events in the progression would just completely change. This was also very hard for sort of even us as playtesters sort of poking at the system and playtesting the game to figure out, because it wasn't clear exactly when stuff was happening. So it's like, oh, well, now you can just tell the player about all these things like, their emotion, but you can't tell the player that, Hamlet's trust in you has increased by 10. Like, what does that mean? Well, maybe Hamlet's trust in you has increased slightly. Okay, well, what does slightly mean? And so Eric mentioned before in his example with Claudius that the game presents you those notifications where the actual like logical predicates are being asserted and retracted. But that's already a lot of information. And now you're tacking on, so-and like this character's trust in you has increased by this much. It's like, oh, that's even more information. And how does that like affect the simulation? So there was that timeline view that Eric showed, and that just shows you based on like the post conditions and preconditions, what might happen, when it's going to happen, how long it's going to take and stuff like that. And that's something that we iterated on a lot. And so like, we didn't even get to the point where we were like, oh, what is the next way to present, a character's trust in you? The system was already too wieldy to play around with, but that would have been like a huge problem we would have needed to have solved. And so the short of it is that, we thought about throwing more parameters at it. And I was really excited about this because I was like, oh man, I'm reading about drama management and like, how you can annotate all of these scenes and stuff with like, all these different parameters and you can tune them and the system is smart enough to like schedule things like based on this. And turns out that adding more knobs and parameters in this particular case did not really work out. And again, a lot of it had to do with time. Eric and I were busy fixing bugs and debugging the system and trying to make the scheduler actually play out Hamlet. And there was a lot, I feel like this is an area that we could have explored much more. We just didn't come up with a particularly satisfying conclusion that wasn't a pain for our writer designers to work with.
Yeah, but I think the takeaway for us is that the pain we end up the pain we did end up willingly like suffering through were the ones where the system was player relevant, right? Like we could show them the state of like Hamlet now wants to do a thing. And we definitely didn't at the time. We did not realize we were making these decisions about like, do we throw more systems at it? Or is that not worth the cost, even though we like felt the pain immediately? So like these two, we made opposite decisions in these two cases. So we ended up solving this emotional arc problem, just kind of like using tooling to help the designers solve it manually. So we did another thing where we tried to characterize the problem. In this case, I think the most egregious example is when you had a character that was extremely upset due to a potentially traumatic event or some other very distressing news, then go to something very lighthearted immediately thereafter. Like that was very jarring. So we added these bits of state to the system about a character being upset, which I think they'd get over overnight, or somebody being like emotionally shattered where they're done for the rest of the loop. So I think this usually this will happen to Gertrude, say, if Claudius is killed. And like other bits of state, the game simulation was not changed to give these any kind of like a semantic meaning. They're just like bits of state. But the idea is, well, now we're going to have every event be flagged like by default. Events are preconditioned on these things not being true unless they're explicitly bought in. And I just want to like highlight a little cool side note about our development practices that I think we should give like a separate talk on, is that we try to do that. So there's the naive ways to add this mechanic to the game. Because like from the player's perspective, this is like a consistent mechanic that's like enforced. You could either dump the burden on the content, where now the designers have to make sure they put the right boilerplate in at every spot to make sure the mechanic is implemented consistently. Or you could try to put it into the game's runtime simulation where the mechanic is like a bona fide piece of the game. But what we did is neither of those, and we stuck it in the middle where we wanted the designers to have minimal boilerplate and the mechanic is largely implemented in the compiler. So the compiler is auto-inserting these preconditions for most events where your characters are not upset or they are not shattered. And it will only not do that if the writer has like explicitly opted into the exceptional case. We did this as well for like, for example, dead characters were a problem during development where a character would die and then we would forget to put preconditions on. So they would get right back up and start going to events again. And we implemented this not by like telling the simulation what dead meant. We did this by having the compiler automatically make sure that events, the high level events the designers were writing, were compiled down to events with those extra preconditions to keep dead characters out. TLDR this is great because you can debug it statically. Like from like a practical perspective, when we were in engineering, this was great because you can debug whether your mechanic was implemented correctly by the compiler without having to like actually run your game to see if it's behaving correctly. You can like just inspect the output code and see if it does what has the boilerplate you expect it to. All right, so just to like kind of like wrap up, what I was talking about, like what we took away from this project and what I hope you all can take away from this talk. The main thing, I guess I was before getting, one of the things reasons I was excited to work on this project was I was just like a young grad student with a bunch of like naive ideas about how AI could help build game tooling or about like cool, crazy simulation stuff we wanted to do. And this was a good opportunity to get some extremely grounded experience in how like that looks when you're busy fighting UI bugs the whole time. And I was like partially vindicated, but partially kind of like humbled greatly, where it is the case that I think fancy design, sophisticated design tools could be really impactful with these things, because the problem we encountered over and over and over and over again is that it was difficult to predict what this chaotic simulation would do, even though the simulation was like doing mostly what we wanted, but there was just a bunch of extra cases and like weird interactions that led to problematic states that we had a very hard time even finding the problems to begin with and then figuring out how to solve them. And that's just like, you've seen several examples of that in this talk, and there was like many, many more we haven't got to. And so the questions I come away thinking about, like if I were to do this again, or if I'm gonna do a spiritual sequel, or if I'm going to try to go help other people building these kinds of games, like the first like specific question is, I'm focused a lot more on how do we make better tooling for these things? Like we have a lot of pretty fancy systems and narrative simulations out there now, but how do we help somebody actually understand what's going on with their content built in those systems? And how do we build tools or help them build their own tools, make this work? Right? There's kind of like, there's two like lenses to think about this. There's sort of like, one is you can build a whole system that you're implementing things in, like say like puzzle scripts, and for like some kind of narrative experience. And because somebody's working in your system can come with tools out of the box that happen to work with things built in that system because they impose strong assumptions on the content. In practice, that would not have worked with a project like Elsinore, where we were in some sense intentionally trying to like mechanically innovate. Like there wasn't a system that did what we wanted to do. And so we were doing what a large number of interactive narrative experiences or other game projects do, which is they're building ad hoc tools for their ad hoc system together, evolving as they go. And so then the question becomes, well, like, how can you help people put those together? I always think about like, what's the equivalent of like parser combinator libraries, but for like building intelligent tooling for understanding my game simulations, right? Like if I'm building a DSL, this is again, it's like something for my background, building a lot of DSLs, you often have to write a parser of some kinds. And parsing is like effectively a solved problem. So there's a lot of tools, not just to make parsers for you, but like libraries in your favorite programming language to help you quickly cobble together a parser, mostly by hand, but like relying on these like powerful tools. So you're not doing all the like painful work. And I want, as like a practicing game developer and narrative simulation builder, I want more things to help me build those kind of powerful tools.
And so sort of a broader question, sort of in the same vein, is like, well, you know, how can AI assist with this at all? Can AI like be a part of this tooling process, and can it help designers better understand or control their narrative experiences? So my day job is working on Minecraft. I work on a big simulation. Lots of things go wrong. And so sort of the lens that I look at this through now is like, what is the equivalent of like automated gameplay testing for giant simulations, except for narrative games? Or like, what's the equivalent of fuzz testing? And how do you sort of detect like things like, what does implausible mean? Is the narrative Shakespearean enough? Does it sound like, we did have a problem throughout development where we would stuff in a lot of temporary dialogue. And it was only through playtesting that in like super obscure cases that we encountered this temp dialogue. And it's like, well, wouldn't it have been nice to have something that sort of like, this sounds simple, but again, it's a tool that we needed to build, which was like, how do we sort of quickly look at our content and look at like the most critical paths and like try and reason about like what is the, what players are the most likely to see, and then sort of fix the dialogue in that order, and specifically fix the dialogue that doesn't sound Shakespearean enough. And this sounds like it's sort of approaching things within the purview of like sentiment analysis or natural language processing. And like, these are all areas that are being like, thoroughly researched. And like, I feel like there's definitely opportunities, if, it hasn't happened already, to sort of start pulling in that kind of sort of artificial intelligence into this space. And something I do want to point out though, is that we spent a lot of time talking about controlling the simulation, but we do really appreciate the cases where things can go wrong. Even though, like, as I mentioned before, yes, we care about making the Shakespearean, but it was really fun and sort of enlightening to find all the ways that the simulation could break down. So in addition to just being able to control the simulation, are there ways for tools to help designers discover things they might not have known about their simulation? So one of my favorite examples, which we had to fix by hand, unfortunately, was there are, like any good narrative game, we happen to have romance arcs. And players quickly found that you could romance multiple people at the same time. And there didn't really seem to be any repercussions for, doing that. And so,
and the content didn't acknowledge it either. Ophelia,
yeah, the content didn't acknowledge it either. So you could literally run around the castle.
There were 5 different affiliates and relationships.
Yeah, so we didn't completely fix this, but when Katie and Connor found out about this, they were like, "Oh, that's hilarious. We're going to patch in a couple of dialogue changes to these specific scenes because players have uncovered this, and we're going to, we're going to at least comment on it as part of the scene if you do happen to be romancing multiple players at once, because again, you can just check whether or not certain predicates are fired to condition a piece of dialogue." And so that was a lot of fun, and I wish we would have been able to sort of explore more of those and find more weird cases where things broke down, because then we could have done cute little things like this more frequently.
Yeah, and I want to mention a broader point about like tools to help designers understand their simulations. A lot of the examples that we've been going over in this talk end up boiling down to like, oh, there's weird stuff that's bad and we need to get rid of the weird stuff. And I don't want you to come away thinking like that's the only mode for this. I think there's a lot, like it happened to be the case that some of those were like conflicting with our aesthetic goals, but there's a lot of times where the weird stuff is like the best part and you want to find them. Like I think about like Dwarf Fortress in particular, for example. I think like the normal mode of consumption of Dwarf Fortress for like the typical person isn't like playing the game. It's hearing about the amazing like 1 in a million sequence of events that led to this hilarious story. And so the question is like not go find the weird interactions because we need to get rid of them. It's like go find the weird interactions because I want to see them. I want like the people experiencing my work to see them. I want like them to be brought to the fore. One of my thinking about like right now, one of my favorite things I've been doing recently is participating in the cultural event of Blaseball. Thank you, Kat Manning, for introducing me to this. And there they take unexpected interactions between mechanics or even things like web server bugs and spin them into like emotionally satisfying narrative arcs. And it's amazing. And it's so designers need to be able to understand what their thing is doing, but not just to exert control over it, but also maybe just to appreciate the like amazing things it's doing in its edge cases. So yeah.
Okay, so I think that's mostly all we have. I do need to give a bunch of acknowledgements. So this is the rest of the Elsinore team. We were all in various places across the US. And this was a long and arduous process that took about 7 years of Sundays to finish. Unlike all the characters in Hamlet, we do not all want to stab each other after this. So we would consider this a success. And then huge shout outs to everybody in the academic community and the narrative community that we've been talking to over the years. There's like way too many to list here. I would be doing a disservice if I put anyone specific down. But I guess one of the big things for us was we showed off Elsinore at the playable experiences for Aiden, I think 2016, and it was a very different game then, but we got a lot of good feedback, and that was a lot of fun. So Elsinore has been floating around the AI and games community for a little while now, and so thank you for all of you who have talked to us about it and chatted with us about it, and also thank you to our advisors for letting us do this secret side project on the side, without complaining too much. We really appreciate it. So that's basically it. If we're sort of happy to ramble, take questions, here's more information if you would like to learn more about the game and what it's about, or just, chat with us about we have lots and lots of great stories from the development of this game because it's 7 years of hilarious Sundays. So feel free to reach out. And that's it.
Yeah, thanks for having us.
If I could start the questions, I have just an endless number and I'm trying to pick the best one.
Okay. Yeah, I've seen the chat has been very lively throughout this talk, so thank you. And thank you for all the good references. I also see that I should have maybe not used facade as my example in that slide earlier.
Oh,
Sorry
no,
that I made the time to facade number.
No, Kristin, it's critical that you used facade in your example.
Yeah, we would have to classify this as maybe not an int talk if you hadn't used it.
I was torn. I wasn't sure to do facade or prom week, but I wanted to do one of them.
I was really curious what you mentioned about how you were just kind of finding bugs or interesting behavior kind of as they arose during QA. And that's a problem that we've run into in the work that we're doing, where we're building these really interesting like interactive worlds, and they're intentionally meant to be like larger than the designer can anticipate by hand. But then the designer needs some tool to go in and say, okay, show me the weird trajectories that I hadn't anticipated. I don't know. And we've got a couple of ideas on that, but I just wanted to know if you had any more insight for what would a tool look like? What should a tool definitely not be like to do that task of finding strange, unexpected branches?
Yeah, I think it depends on what strange means and what you want to do. Like I mentioned this briefly in the talk, but like because of our background, both as like engineers and mine in particular, doing program synthesis for my dissertation, I thought of it a lot as like similar to trying to find bugs in software engineering, and you can leverage a lot of the tools there towards this. So part of that was like trying to do like straight up verification or whatever, but I think part of it was also this was why we took like the language centric approach we did to the project, where it's like an equivalent of trying to design a programming language and environment around it that like helps a programmer not make bugs in the first place. Can you design your tools to help your developers not make certain kinds of weirdness that they definitely don't want in the first place? But that doesn't help you at all with like, go find me the interesting stuff, because I just want to see it. Maybe, right? That seems like you need a totally different approach from like a different field. And that's why I was thinking more kind of like bringing natural language understanding of some kinds.
Did you do any automated, like just have an automated version of the player make a bunch of random choices and see what happens style?
Yeah, we did a little bit of that. And then I actually tried to get it running in like the tools that I used outside of it, like SAT solvers or answer set programming or whatever. But when you're designing the engine or when you're designing the simulation, like your first concern isn't like, is this thing amenable to like random rollouts or formal reasoning? And so you end up we ended up making it a little hard to do so. And at that point it was like, well, I got to fix these UI bugs. I can't spend time going back to first principles. So like something I'd actually really kind of like, what's like, not just tools, really, like what's the equivalent of like best practices for like structuring your simulations so it is amenable to these kinds of things, right? Like, I mean, like software developers have a ton of ways, like they structure the code in such a way to try to like head off future maintenance issues down the line. Like you try to be modular about things, you try to minimize the state you have or whatever. Like, what are those like tricks of the trade and best practices for like, do this when you're building random simulations, and then maybe you'll be more easily able to roll things out. We did it a little bit in that the narrative engine is actually a completely separate component from the games, like the visuals of the game and the characters walking around. That's all just kind of like a puppet show that's presenting the simulation that's already decided what's going to happen. So you could have made like a textual version of Elsinore, which maybe I'll do someday if I ever have spare time where it's like pure text only. And so that was like something we were trying to do so we could at least do rollouts, but it was too complicated for me to model using constraint solvers or other symbolic reasoning.
Thank you.
I like the chat question of, so since Elsinore is a commercially released game, did you ever have to balance effort, since this is a 7-year project, versus profit?
I can take this one. So as I mentioned before, this was a side project. And it was a side project for everyone on the team. So I think there were a couple instances where people were working on it full time, but not many. And so we all had full-time day jobs that sort of allowed us to live and eat. So I think one of the nice things was, because this was a side project, it meant we were able to take risks. Because like if you had asked us like, oh, go make a game to like actually make money, we would not have made a single player narrative experience that had finite numbers of endings that you could hypothetically discover once and then never have to play again. Like that's just not like a good like best-selling like sort of that doesn't make that isn't like a game that's going to make us a lot of money. Also, it's Shakespeare, so a lot of people have like really bad memories of, you know, studying Hamlet in like high school. So going to conventions was always like a "ew Shakespeare" or "ooh, I was an English major in college and I really love Shakespeare." And so it was like a wild spectrum of like people who were super not interested the moment they heard Shakespeare, people who were very interested in it. And so like it was often a very hard sell.
Well, although this makes me kind of like, I think the most common response we get at conventions is like, this is kind of weird, but my wife or sister or mother who doesn't play games would like it, which was like a little depressing in a way, but also kind of exciting that like an audience of people who, I don't like games, but do like Shakespeare, were kind of excited to try it out.
So, I mean, the reality of it is that we rarely thought about balancing effort and profit. I think towards the end, it was more like, we've been working on this game for 7 years, and if we work on it any longer, these ideas will be stale because we will have like effectively worked on it for 7 years. I mean, it wasn't, you know, if you sort of condense all of it, it's a couple of years of development, but you know, the industry changes fast over the course of the 7 years that we spread that development out. So we didn't really think about profit. We were fortunate enough to be in a position to not think about that because of, again, the full-time job, everybody else had full-time jobs thing.
I treated it like a hobby that paid for a bit of itself.
Yeah.
More than a method to pay for rent.
Yeah.
So
and we were fortunate. We did manage to get crowdsource funding sort of we kickstarted successfully 1 year and got a little bit more than we expected. But then it turns out that, you know, making games is expensive. So we quickly blew through that. And so I hope that was able to answer the question.
As for time management, it was convenient that most of the core team were close friends before this started because we'd all gone to undergrad together. And that was pivotal in keeping things working smoothly because you could fall back on existing trust and love for each other to like power through tough moments. It's not very practical advice, but that was, I think, an important part of this, why this project works.
Also, Chris, thank you for all, and everybody in the chat, thank you for all the links. I'm going to download this whole chat as a giant file and pour through it later. So, yay.
Oh, wow, you can do that.
Yeah, we automatically get the transcript when the meeting ends. Any other questions?
I guess I kind of have one, which is, are you interested in continuing work on this project, or is it kind of it's in the past and you want to move on to other things now?
We're exploring trying to maybe do like extra work like console ports and stuff, which is going terribly because reasons that are not interesting. But the like content is basically done. I think like Katie and Connor are kind of like finished with tweaking the substance of the game.
Yeah, I guess by this as a project, I kind of more meant like, I don't know, like you know, if there were a sequel or a spiritual sequel that used similar
yeah.
simulation technology or something like that, where you were trying to do kind of similar simulation-based narratives.
We're having like, we're at the like idle discussion phase of what like a next project might look like. There's a good chance it would be something radically different, like exploring another genre that we care about that is less like purely narrative focused like this. So I think they'll always have some kind of narrative component and some kind of simulation component. So I think like a lot of our ideas and concerns will carry over to a future project, but I couldn't say exactly what that would look like right now.
Yeah,
Sounds
I think
good. Thanks.
unfortunately one of the things that's both good and bad for this project is we picked Hamlet as sort of the Shakespeare play to tackle with this. And that's the one that has like the most stuff written on it. So it was like pretty easy to just like find stuff. But if you were to say, take a play like, oh, what's something super obscure, Titus Andronicus, then it's like, oh, well, now all of a sudden we have, that's completely different. So I guess the question we do get a lot is like, what play will you do next? And the answer is, I don't know if we've been able to figure that one out.
One of my mentors for my thesis did a lot of chose Madame Bovary as her like main example, which is just niche enough, I think. And then I used a play called Tamara, which is a like a 20th century play, but it has like a lot in common with Sleep No More.
Okay.
In that it's a multi-room kind of simultaneous action immersive theater experience.
Yeah, I think if we were to revisit this, I personally would be interested in sort of breaking away from Shakespeare. But I think a lot of people were expecting like, which one are you going to do next? I'm like, oh, I don't know.
I see.
Yeah, but yeah, I mean, Eric and I did talk sort of a long time ago. It was like part of our original motivation for, and he mentioned it before, for decoupling the engine as much from the rest of like the rendering and sort of like the game presentation of it, was to prepare for something like that. And yes, in the end, we did have to hack a bunch of stuff together, and we did bake a lot of the stuff in, but we did try to keep it as separate as possible. So there is a future in which we could return to it like fairly easily. We at least sort of like left ourselves that like that sort of avenue to like revisit this, which I think was super nice.
Some of our original ideas were a lot wackier that I think would be worth exploring. Where one of the things I tried was, instead of like you experiencing the narrative in time with it, just instead representing it like totally abstractly, where you're just like deciding where to stick in intersection points, and it like immediately shows you how it plays out. And so you're just like kind of playing directly with the graph by looking at a slice, like a single path through it. But this was not appealing to the other people on the team, so we went more with this one. But I still think like totally wacky kind of non-linear presentations of interactive narratives is something I want to play more like that. I'm sure some people have done some things I'm just not aware of, and I want more people to make things like that.
Sorry, I have more to say, but I don't want to take up everybody's time.
Okay, great. So with that, let's thank our speakers once again. And this ends our keynote session. We'll be back for our paper session in 10 minutes. See you guys.
Thank you.
I wanted to make sure people had permission to leave before I kept rambling on it, you guys. But I was wondering the kind of meta narrative mechanics that you were just mentioning, Eric, makes me think a little bit about Stephen Lavell's Theatrics game. Have you seen this? It's like a little web game where you kind of manipulate characters by dragging and dropping events that have preconditions and effects.
What's it called
again?
again?
Try to tell a specific story, like you try to make the story have a particular outcome.
I don't think I've seen that particular game.
It's like a very
million games.
Yeah. No, I know there's too many games, but I don't know. It seems like a particularly interesting kind of like cartoon representation of procedural storytelling that I feel like could be a nice fit for, like, it would be fun to see the theatrics version of Elsinore.
Probably we'll try to do at least text version at some point. It seems worth it just to make an accessible version of the game, like where it's just outputting to HTML or something, text only, instead of being stuck in a game engine.
Yeah. I
That'd be
don't know.
like
The 3D was hard. The 3D was very hard.
The main thing I learned is don't make 3D games as indie projects. Just don't do it. Just don't do it.
Yeah.
Can I ask you something about just based on that very brief snippet of your representation of the preconditions and postconditions?
Yeah.
We use a really similar representation in planning systems. And something that I thought was interesting based on your representation, it looked like you had a lot of like intentions as preconditions. Like a lot of the intentions took the form of like somebody wants this or somebody intends this.
Yeah. So it's just, I mean, I can like actually just show you some of the raw.
Oh yeah. The reason I ask is that we've usually treated intentions as like a second order thing. Like characters have goals, which are like specific like predicates, like they want somebody to be dead or
yeah, everything in Elsinore is just first order predicates, but there's just like a bunch of functions you can combine them into like art, right? Like, so just wants and believes and all that stuff are just functions you can use to build predicates, but like they don't have any meaning. So that's why there's no, there was no need, because like all of these things are given meaning only by how the designers use them in event preconditions. There wasn't any like need to separate them. Like in that way, where I think a lot of other systems do it because they do treat them specially. And so that's why I was just, well, we went with the thing that was easiest for the system and easiest for the designers, which is to keep the simplest kind of representation.
Yeah, that's great. And I think a lot of that is based on, perhaps this thought that maybe designers will want, intends and believes and these predicates to have a certain like modal meaning, but maybe not. I mean, maybe your writers just had no trouble dealing with them just as, predicates like any other.
Yeah, where's...
Yeah, because I think I sort of at a bare minimum, like, so like, yes, the engine doesn't really understand like what like wants and believes are like per se. The only thing that really affected was the formatting. So it was like, oh, because this is a wants predicate and we know that we have defined this wants predicate, we have like special formatting for it that will like show up in the notification. And I think
here's all the type declarations for the predicate logic.
There we go.
There's just like, and this is just like the designers have what they want. And the only thing this does is it puts some like type checking on them. So like you want to avoid a particular character, so checks to make sure you like actually put a real character in there just to catch typos and things, but that's kind of the extent of it. And then the standard top-low predicates that most events are based on are these ones. Like, is someone dead? Do they want something? Do they believe something? Do you have a piece of information already? Are certain doors accessible?
And all these things like once has no meaning. It's just something that the designers know to sometimes write as a precondition in effect.
Yeah, and then like the actual things are just these like JSON blobs where like you just write in the preconditions here. Yeah, more of them. We originally, the conditions are in CNF, and before we had a converter, I made the designers write it in CNF directly, which is why it's this list of a list. And then eventually we made it better for them and they could write like normal people Boolean expressions and it converts them, but most of the game is still in that form. Yeah, you can see they sort of feel a little more complicated. Yeah, that's I think
that's really interesting. And your idea of a sort of compiler pass, I wonder if you could get some of that out of adding meaning to those, like having tools that, like one of those was like has seen, like you could derive that from like, were they ever in the same place at the same time in the past?
Well, yeah. I mean, actually, I can show a little more. Like that's how some of what we did. We're trying to find some like scenes. Like if you look at the scenes here, they're pretty. These are the scenes the designers actually work with, which are mostly kind of, there's some conditions, but it's mostly straight line code. But then if you look at, let me open an example of the compiled ones.
There was a lot of compiler stuff in this.